Hello and welcome to Virtual CB1A. This is Ma'am Rena and this is Week 1, Lecture 2 of Logic and Set Theory. Today, we will talk about more on sets. These are the kinds of sets, relationships between sets, and of course, the power sets. So let's start with the kinds of sets. First, we have what we call the empty set. It is a set that does not contain any element. It is denoted by the symbol or by the pair of braces with no element inside. This one. It is also called the null set or void set. Let's look at this example. The set of odd numbers in the English alphabet. Let's analyze. Meron bang number sa English alphabet? Right. Wala. So, puro letters lang ang nasa English alphabet. So, this is an example of an empty set. Next. Number 2, we have the finite set. This is a set with countable number of elements. As long as you can count the elements inside the set, it will qualify as a finite set. For example, the set of vowels in the English alphabet. How many vowel letters do we have in the English alphabet? Let's write it in tabular form. So let's say set A is the set of vowel letters in the English alphabet. The elements will be A, E, I, O, U. How many elements do we have? 1, 2, 3, 4, 5. So we have 5 elements. Kaya natin siyang bilangin. This is a finite set. Next, let's go to the third kind of set. We have the infinite set. This is a set that has uncountable number of elements. Let's take this as an example. The set of integers. Kaya ba nating bilangin kung ilan yung laman ng set? Or can you even name the highest integer or the lowest integer? O di ba hindi? Therefore, this is an example of an infinite set. Now let's go to number 4. We have the universal set. So this is relative. Your universal set depends upon the context of your problem. A set containing elements of a problem under consideration, and it is denoted by the symbol U. You have to take note that if a certain universal set is not given in your problem, you will assume that the set of real numbers is your universal set. At least, kahit dito lang sa course na to. So, for example, our universal set is the set of real numbers. So, it depends upon the context of your problem. Always remember that. If you didn't find any universal set in your problem, then you will assume that it is the set of real numbers. We will talk about it later. Now, let's go to relationships of sets. First, we have the equal sets. These are sets with exactly the same elements. For example, let A be the set where X is a distinct letter in the word near. And let B be the set of all X such that X is a distinct letter in the word earn. So let's write them in tabular form. The elements here are N, E, A, and R. While for this set, the elements are E, A, R, and N. Now let's look at the elements inside both sets. N is here. Also, it is in set B. E can be found on both sets. Also, A and R can be found on both sets. Nothing more, nothing less. Exactly the same yung elements nila inside. Therefore, sets A and B are equal sets denoted by A is equal to B. So we are going to use the equal symbol since both of them have the elements A, E, R, and N. Now, if you are given with a set that has a lot of elements inside, finite pa rin, pero masyado marami yung element inside, this is my tip. If you are going to write it in tabular form and you are going to check if they are equal or not, you can write the elements in alphabetical form. That way, it'll be easier for you to check if the elements match the elements on the other set. But that is optional. That's just a tip. Okay, now let's go to the second type of relationship between sets. We have what we call equivalent sets. These are sets with the same number of elements. So all you have to do is to check the number of elements between the two sets. If they are the same, then they will be considered as equivalent. For example, we have set A having the elements A, B, C, and D. And set B with the elements 1, 2, 3, 4. So how many elements do we have in set A? Alright, we have 4. Now in set B, how many elements do we have? Correct, that is also 4. Since they have the same number of elements, sets A and B are equivalent sets. And this is denoted by the symbol. So this is read as A is equivalent to B, since they have the same number of elements. And you have to take note of this. Equal sets are equivalent sets. However, not all equivalent sets are equal sets. Now let's go to item number 3. Joint sets. Sets with at least one common element. For example, set E is the set containing 1, 2, 3, 4, and set F is the set containing 2, 4, 6, 8. Do we have common elements? Alright, 2 and 4 can be found on the first set as well as on the second set. So since the numbers 2 and 4 can be found on both sets, E and F, then these sets are joint sets. Basta nagkaroon sila ng parehong element inside, kahit isa lang yan, they will be considered as joint sets. For number 4, we have disjoint sets. So these are sets that has no common elements. For example, set G with the elements A, B, C, D, and set H with the elements 10, 11, 12. Meron bang parehas? Okay, wala. Then, this is an example of disjoint sets. Let's continue. We have what we call the subset. Ayan, medyo malawak to. A subset is a set in which every element can be found on another set. The symbol here, ayan, para siyang C, is read as a subset of, while the symbol here, the one with the slash, is read as not a subset of. Take note, minsan nababaligtad to. Sometimes you will encounter symbols like this and symbols like this. How are you going to deal with these symbols? Para lang silang greater than or less than. So, relative yung subset sa kung sino yung nandun sa opening. So, dito, if we are talking about the greater than symbol, the bigger set or the bigger number pala is always in the opening and the smaller number is on the pointed side. Ganon din pagdating dito. The bigger set is on the opening and the subset, yung mas maliit na set, is on the curved side. Let's have an example. A is a subset of B. And these are our sets. A is equal to 1, 2, while B is equal to 1, 2, 3, 4. So all the elements in set A can be found on the elements in set B. So set A is inside B. Therefore, A is a subset of B. Is it clear? I hope it is. Alright, now let's define improper subset. If the first set equals the second set, then it is an improper subset. And this is denoted by this symbol. Meron siyang parang equal sa baba. We always write a line below our symbols to denote that they are also equal to. So, pakitake note nun na, pakitandaan. And also, another type of improper subset is a null set. A null set is always a subset of any given set, and it is considered an improper subset of the given set. So, for any given set, there are always two improper subsets. One is the set itself, and the other is the null set. Okay? So, other than the null set and the set itself, all are considered proper subsets. Now, ayan. We have the power set. This is the set containing all the subsets of the given set with n number of elements. Is called the power set with 2 raised to n number of elements. Medyo magko-compute na tayo, pero minor computation lang naman. Let's look at this example. Let P be the set of the last 3 letters of the English alphabet. Find the power set S of set P. Okay. So, we are going to find the power set S of set P. Let's exit this presentation. Discard natin siya. And let's go to this notepad. Okay. Now, let's compute for the power set of P, which is set S. First, let's enlist the elements of P. So, according to our definition, P is the set of the last 3 letters in the English alphabet. So, these are X, Y, and Z. Now, for us to get the elements of the power set of P, which is S, first we have to get all the subsets of P. And we have 2 groups. First, we have the improper subsets. And next, we have the proper subsets of P. For the improper subsets, laging dalawa lang to. From our definition earlier, we have the empty set and the set itself, set P. Or, pwede mo rin naman siya isulat as the set containing X, Y, or Z. Now, for the proper subsets, let's start with the set containing only the element X. This is a subset of P. Next, the element Y lang ang laman. Next, we have the set containing only the element Z. So, these are the proper subsets of P containing only one element. Now, let's go to the proper subsets of P containing only 2 elements. We have the set containing XY, the set containing XZ, and finally, the set containing YZ. Now let's check. According to our definition, we can check for the number of subsets by using the formula 2 raised to n, where n is the number of elements in the given set. How many elements do we have? 1, 2, 3. So this is 2 raised to 3. We can expect our power set to have 8 elements, or we can expect our set P to have 8 subsets. Let's count. How many subsets do we have? We have 2 improper subsets and 6 proper subsets. So all in all, we have 8 subsets of the set P. In order for us to get the power set of P, which is S, all we have to do is to write down all the subsets as the elements of our power set. Let's start with the null set, followed by the set itself. If you are going to use P, please do not write XYZ. Or if you are going to write XYZ here in your power set, please do not include P. Only choose one among these two. For the set containing one element, let's start with the set only containing X, followed by the set only containing Y, the set only containing Z, and the set containing two elements XY, followed by the set containing the two elements XZ, and finally the set containing the elements YZ. And of course, enclose them within a pair of bracket. Please separate them with a comma pa rin. So our subsets will serve as the elements of our power set S. So I hope I made everything clear. This is the end of our lecture 2, and I will see you again, or please check out my next video for lecture number 3 for week 2. This is all for today. Thank you and have a good day. Bye!